Hey everyone, I'm back. In this video, we're going to start a new chapter. We finished up our chapter 8 test the last couple days, and what I want to do today is actually skip to the very last chapter in the book. We have 3 left. There's chapter 9, which was more about quadratics, solving quadratic equations more than graphing them and factoring them. I honestly think that is probably one that I'm just not going to get to this year. Chapter 11 was about a topic, square root functions, that is not really in our standards, so I'm not really worried about chapter 11 at all. Chapter 12, though, is the one that I want to look at. It's about data displays, because we really hadn't touched on data displays at all, and it had its own category in our standards. And so since we really have barely touched that besides the stuff we've done on scatter plots, I wanted to make sure that I did this information with you guys before the year's over, just because it had its own complete category on our big poster of standards, and I would feel bad if we didn't even get to anything in the whole category or the whole subgroup about data displays, data analysis. So this chapter is all going to be about different data analysis, and today we're going to look at measures of center and variation. And we've already seen these words before, most of them in this lesson, so this should be a nice little change from some of the stuff we have been doing that may have been brand new to you guys. And so I'll do the best I can. It's going to start out pretty easy, but we'll end up with something that's a little more complicated than maybe what this is. Because if you're reading my board right now, you're like, dude, I already know how to do all this, right? Measures of center. I don't know if your 5th grade, 6th grade, 7th grade teacher actually called it this, but when you find the measures of center, what you really are doing is mean, median, and mode. You're like, wait a second, range is in there too. Well, range is not a measure of center. We'll get to range in a minute when we talk about variation. But anyway, what we're going to look at in this lesson is measures of center first, mean, median, and mode, and then we'll do in a second measures of variation, which is going to be range and then something else. So measures of center, I just put it in there because I was running out of space. Measures of center. The 3 that we're going to have in our chapter, in our lesson, is mean, median, and mode. You probably already know what these are. Measures of center, what do? They represent the center or the typical value in a data set, in a big group of numbers. So here I just made up a data set in case for some reason you haven't paid attention the last 4 or 5 years of school and you need an explanation. All right, the mean is where you add up all the numbers, divide by how many numbers there are. And a calculator is going to be your best friend. So if you wanted a calculator for this one, which actually you could probably add this one up in your head, but just for the sake of time, I'm going to add all these up. I got 30. I'm going to divide by how many numbers there are. 1, 2, 3, 4, 5, 6, 7, 8. 30 divided by 8 gives me 3.75. Now, that is the mean. Now, I don't think you've probably ever done this before. Here's the symbol for mean, like the statistical symbol for mean is this. It's called X bar, and that's really what you call it, X bar, because it's got an X with a bar on top of it. So we've never really used this in my class before. I don't ever teach this in my regular 8th grade math class, but when you get to the high school and you get into a statistics class, you'll probably have to write it like this. X bar equals 3.75. That's the same thing as the mean. Okay, the median is where you put the numbers in order and then you find the number that's in the middle, right? But you've got to put the numbers in order first. To be honest, you can put them in order either way, greatest to smallest or smallest to greatest, but most of us always just go smallest to greatest because that's the more natural way to do it. And so here is my list of numbers. Make sure you do a double check. Make sure you have all 8 of them in there. 1, 2, 3, 4, 5, 6, 7, 8. I always seem to forget to do that, and then sometimes I'll leave numbers out. I like to cross them out. 2 on the left, 2 on the right, 3 on the right there. Okay, so we have 2 in the middle right there. When you have 2 numbers in the middle, I hope you know what to do. You add them up and divide by 2. You find the average of those 2 numbers. Or that's 5 divided by 2. 5 divided by 2 is 2.5. Or common sense, you can just say, hey, what's halfway in between 2 and 3? And obviously it's 2.5. There is no fancy symbol like we had here, X bar for the mean. There is no fancy symbol for median that I know of anyway. So I'm just going to call it the median. And then the mode. The mode is the number that shows up the most in the list. There could be no mode if all the numbers are in there the same amount. There could be multiple modes if we had a couple numbers that were in there the most. The mode could be anything. So here it looks like we have 3 number 1s, and so our mode is 1. That's it. Okay. Now what they're going to ask us to do At the beginning of the lesson today, in the questions that I give you, it's going to ask you, find the mean, median, and mode. That'll be easy. We just did it. And then it's going to say, choose which one of those answers represents the group of numbers the best, right? Which one of these answers most represents our data? And so what you're going to be looking for whenever you do that is which answer is most similar to the numbers up here, right? I would not pick the mode. Now, the mode is the only one that's not a decimal, but you see how the mode is smaller than like all the numbers? So the mode, if I said, hey, this list can be represented by the number 1, no, because really almost all the numbers were bigger than 1. The 1 is way smaller than most of the numbers. So I'm not going to pick the mode. When it comes to these two, these are both pretty close. To be honest, I might pick the 3.75 just because most of the numbers are maybe a little bit bigger than 2.5. But anyway, usually it's pretty obvious. I didn't do a very good job of making an example here, but usually you might have a number like this where the number 1, which is smaller than all the numbers in the list, they might give you one that has something that's really, really big. Like, for example, maybe the median was like 9, right? And if the median was 9, you'd be like, oh, wait, most of the numbers are less than 9. And so sometimes it'll ask you which one is the best representation, and when it asks you for the best one, you just want to pick the one that's most similar to all the numbers. You don't want to have a representative here that's smaller than all the numbers. You don't have a representative that's bigger than most of the numbers. If one of them is a decimal and the other one's not, and most of the numbers are not decimals, I probably would have picked the one that wasn't a decimal. But here we had both decimals, so that wasn't the best example. But anyway, if you don't get those questions right, it's not the biggest deal in the world. Okay. Now, what they will do is they'll also talk about outliers. And we mentioned outliers when we actually talked about scatter plots. And so outliers are, whoa, sorry about that. Outliers are numbers that are different, either way bigger or way smaller than all the rest of the numbers in your list. Now, this is the list that we just did. I just copied it down off of the other board. There's actually a mathematical formula that'll help you find the outlier, but we're not going to talk about that today. Today, you can just look at this. Is there one number that seems to be way bigger than all the others? Yeah, sure there is. It's this one, right? All the others are single-digit numbers, and then we have 12, which is twice as much as the second biggest number. So if they ask you, hey, remove the outlier, so they're going to say remove the outlier, take it out of the list. So we're going to cross this out. It's a number that's way bigger than all the others, or it could have been a number that was way smaller than all the others, and knock it out of the list. And now it's going to say, do the mean, median, and mode again, and see how your answers change. So here's the mean, right? If I'm going to do the mean of these numbers over here, the number 12 is now gone. So I'm not going to have 8 numbers in my list anymore. I'm just going to have 7. 4 plus 6 plus 1 plus 2 plus 3 plus 1. Probably could have added that in my head. 18 divided by 1, 2, 3, 4, 5, 6, 7. Equals this. Oh, geez, I'm going to round it. About 2.57, right? So the mean, about 2.57. And the median, if I took the number 12 away, now look what happens to the median. If I put the numbers in order from least to greatest, 1, 1, 1, 2, 3, 4, 6. There's the numbers in order. And I want to go take this one away, 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 this one away. So I got 3 on the right, 3 on the left. So here's my median. The median is 2. And then what happens to the mode? The mode is, the mode is still 1 because the number 1 is still in here 3 times. And none of the other numbers are in there that much. So what they'll ask you is remove the outlier. We just took the number 12, wiped it away from the list. I calculated the mean, median, and mode without the outlier in there. And now it'll say, compare that to your previous answers, which you remember here were our previous answers right here, right? Let me copy those down. So this is with the outlier, right? With all the numbers in the list, with all 8, here's what we had on our first answers. The mean was 3.75. The median originally was 2.5, and the mode was 1. All right, so here was our first list of answers. And then over here was our second group of answers. This is with the outlier removed, right? Without the outlier. We took away the number 12. And so it's going to ask you what happened to your answers. Well, just be obvious, right? You don't have to make up an earth-shattering description here. I could say, all right, the mean, or the x bar, the mean started at 3.75 and now it's 2.57. So I could say, okay, what happened to the mean? The mean went down or decreased by, I'll just subtract them, 3.75 minus 2.57 because I rounded it. The mean went down by 1.18. What happened to the median? Well, the median started at 2.5 and now it's 2. So the median went down, or decreased would maybe be a different word I could use, down by 1/2 or 0.5. The mode was 1 and it's still 1. So the mode stayed the same. The mode did not change. So if it asks you to do that today, don't stress. It's easy, right? Do the mean, median, and mode with the original group of numbers, then take away the outlier, act like it's not even in the list anymore, completely cross it out. Do the mean, median, and mode again, boom, 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 and then just compare them. Subtract them. Sometimes they'll go up, sometimes they'll go down. Depends on if the outlier's the biggest number, everything's going to go down, except for maybe the mode. If the outlier is one of the smaller numbers, everything should go up, with the exception of maybe the mode. All right, so those questions should be easy. You all are very familiar with mean, median, and mode, and we've talked about outliers before, so I'm not really too concerned about mean, median, and mode, measures of center. Now, we're going to switch it over. Instead of measures of center, we can also talk about measures of variation. Variation, or a variable, right? So how much something varies is how much it changes, how much it's different than everything else. And so in our class, we're going to talk about 2 measures of variation. Range, which you've heard of before. You've been doing that for a long time. Standard deviation, which maybe you've heard of it, maybe you haven't, but that's one you've never probably calculated before. And it is a little bit more in-depth. It's not crazy, but it's a little more in-depth. Okay, what do measures of variation do? Measures of variation describe the spread or the distribution, right, how far apart things are of a data set, right? The spread, how far spread apart they are. Like right now, how socially distant they are, right? So, for example, here's a list of numbers. I just made them up. If I wanted to find the range, I don't think there's a fancy symbol for the range. Most of you know the range is the biggest number minus the smallest number, right? You just subtract it. Biggest number minus the smallest number. And it's a simple subtraction question. You just have to find the biggest number. The biggest number here, it looks like, is 13. The smallest number is right here. It's 2. And so you just do 13 minus 2. And so the range is 11. Easy, right? That's like a 5th grade, 6th grade question. What you haven't done before is standard deviation. And standard deviation is kind of crazy. It involves a lot of steps. Let me show you what the steps are for how to find standard deviation. Look at this. How to find standard deviation. Step 1, you find the mean. Okay, not too bad. Step 2, find the deviation of each data value. That means tell me how far away each number is from the mean. Then, number 3, you take each one of those answers, you square them. Then you find the mean of those answers, which is called the variance, and then you do the square root of that answer, which is going to give you your standard deviation. So it has 5 steps. This board looks very complicated. It's not as hard as it looks. In fact, it's not very hard at all. This just makes it look very, very confusing. So I'm going to keep this board just kind of off camera. Let me show you. Let's do these. Don't have a panic attack about these. It's not as bad as it's going to look. Okay, that whole board looked very scary. How do you find standard deviation? Right here. You find standard deviation by first doing the mean. We know how to do the mean, right? So step 1, we're going to find the mean. All right, I'm going to add all these up. I'm going to divide by how many numbers there are. Just give me 1 second. Calculator will be handy, although I could probably do this in my head. But for the sake of time and making sure I don't make a mistake, I'm doing all the numbers. I got 70, right? 70 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, okay, that's easy. So 70 divided by 10 is 7. So my mean, or remember what we call it, x bar, the mean is 7, right? 70 divided by 10. Okay, step 1. Done. I did the mean. Now, step 2, what you do is you find the deviation, right? The deviation of each data value. That means each number in the list. Basically, that's a fancy way of saying, tell me how far away from the mean is each one of these numbers, right? So it might, I'm just going to make, sometimes it helps to make a table, but I don't have a table already drawn, right? Here, it's so easy. It just looks very crazy. So what I should do is just have you guys write down, or I'll write down, how far away is each one of these numbers from the number 7? How far away is 3 from 7, right? It's 4 places away, right? Or you could say -4 if you're wanting to subtract it, but I always think of this in positive. How far away is 3 from 7? It's 4 places away. How far away is 5 from 7? It's 2 places away. How far away is 6 from 7? 1 place away. How far away is 2 from 7? That's 5 places away. How far away is 8 from 7? Okay, it's 1 number bigger. How far away is 9 from 7? It's 2 places away, right? How far away is 7 from 7? Okay, 7 is 7, so I'm going to put 0. How far away is this 7 from 7? Well, it's also 0. How far away is 10 from 7? I'm just subtracting them here, right? How far away is the number 13 from the number 7? That's called the deviation. How far are you deviating from the mean, right? So I should have 10 answers, 1 for each of my numbers up there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is my list of how far away each number was from the mean. Okay? So we take all these answers. These are called the deviations. And then we square them. Okay? So then we square them. We just take all these answers and square them, right? We know how to do that. 4 times 4. 2 times 2, 1 times 1, 5 times 5. I'm just taking the number right above it and squaring it, right? 1 times 1, 2 times 2, 0 times 0, 0 times 0, 3 times 3, 6 times 6. Okay, so there are all of the deviations squared, and now I find the mean of these answers. So now I'm going to do the mean again. I'm just going to do the mean. I'm going to do the mean of those numbers. So let me clear out my calculator. Clear. I'm going to do 16 plus 4 plus 1 plus 25 plus 1 plus 4 plus 0 plus 0, which I really didn't need to type, plus 9 plus 36. I get 96. 96 divided by 10 should be 9.6, and it is. 96 divided by 10 equaled 9.6. Okay, that number is the mean of the squared deviations. This is called the variance. If you really want to know, it has a fancy word, fancy title. That's called the variance. We're almost done. The very last step is to do the square root of this number. So let me move my board up a little bit. So now I just do square root of the number we just got. We just got 9.6, so I'm going to do square root of 9.6. It's got to be 3 point something, right? So I'm going to clear this out. I'm going to do second square root sign, square root of 9.6, 3.09. So I'm going to round that to 3.1. Okay, we did all of that to get the number 3.1. You're like, oh, geez, that was a lot of work. What does this mean, all right? How would I write this as an answer? I would say, if I had to write this out, I would say I don't say on average. I would just say, in general, each number in this list, a number in this list is 3.1 away from the mean, right? Typically, a number in the list is 3.1 places away from the mean, which remember the original mean was 7, right? So that's basically what you're saying with the standard deviation. Standard deviation also has an abbreviation if you don't want to have to write this out. I think I can't remember what the name of the sign is, but it looks like this, like a 0 with a little line on top of it. I'll have to look that up in our book. To be honest, I don't use it very often. So that is the symbol for standard deviation. Kind of looks like a sideways music note for those of you all in orchestra or band. Okay, let's do that one more time because that's kind of confusing, and we've probably never done it before. This will be my last part of the video. All right, look what I did here, guys. This is the actual number of coronavirus, COVID-19 cases in certain counties around Missouri right now. This is the actual amount. I went on the website today and took the number from the Johns Hopkins website. And so what I want to do is find the standard deviation of this group of categories, right? This group of numbers. So I've still got my little cheat sheet right here, right? If you want to, like, pause the video whenever you have to do this, you can pause the video right on this this part, and it'll give you the steps to find the standard deviation. So pause it if you want, because I have to have it right off to the side. Step 1, find the mean. Okay, so I'm going to use the fancy symbol X bar. Let's find the mean of all these. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 different counties. Saline County, 211. All right, that's obviously Marshall, Slater. Pettis County, which is like Sedalia, 56. Boone County, that is Columbia, that is Ashland. We have Jackson County, that's Kansas City, only 373. Look how close we are to Kansas City. We have St. Louis City. The actual city of St. Louis is its own county, 1,450. That's where a whole bunch of them are. Randolph County. Randolph County is like Moberly. They only have 8 in all of that county. We play them in sports, right? Livingston County, that is Chillicothe. They only have 4 in the whole county. Callaway County, that's Fulton. We've played them in sports. That's 23. And then Audrain County, that is Mexico. Mexico only has 1 case of the coronavirus that's been confirmed. Okay, I added them all up. I got 2,224. Hopefully you can see that on my calculator. I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 9. So in my list, I get this, 247.1. Let's just round that to 247, just for the sake of not having decimals in anything. So we're going to act like our mean is 247. All right? Okay, step 2, find the deviation of each data value. How far away is each county from the average, from the mean? So I'm going to put deviation. There might be a fancy symbol for deviation, but I don't know. I'm not a person who's done statistics in a while. Okay, so let's just take each county and see how close it is to 247. How close is Saline County to 247? You can probably subtract that in your head, right? 247 minus 211, that is 36. Saline County is 36 below the average, at least this average. Pettis County, 247 minus 56. Okay, you're going to need a calculator for that. It's got to end with a 9. Oh, no, end with a 1. Sorry, 191. Pettis County is 191, smaller than the mean. Boone County, which is Columbia and Ashland, they only have 98 cases. They have a lot more people than us. Let's see, let's do 247 minus 98. Boone County is 149, smaller than the median. Or I keep saying median, than the mean. Jackson County, that's Kansas City, Raytown, all types of people live there. They only have 373 cases. They've been amazing. Minus 247. They are only 126 above the mean to have all those people. St. Louis City, they have the most, 1,450, at least in our list. Minus 247. They are way above the average. They're 1,203. That's obviously where most of the people who have the coronavirus are in our state. Randolph County, which is Moberly, they only have 8 in their whole county. Moberly is just as big as us, and they only have 8 people. They are 239 below the average. Livingston County, they only have 4. Okay, do I really need to? I can do that in my head. 247 minus 4, that's 243. Callaway County, that's Fulton. They're at 23. I can do minus 23, and I would get 224. And then Audrain County, that's Mexico. They only have 1 confirmed case of COVID-19 in their whole county. And they have 25,000 some people in their county. That's about as big as us. 247 minus 1 is obviously 246. So they are 246 below the mean in our list. Okay, so I did the deviation. I found out how far away each number was from the mean. Okay, here's step 3. Square all these numbers. Oh, geez. You're going to square these right here. This is going to get definitely pretty crazy because this is going to be a lot of big numbers that are getting squared. I probably shouldn't have done this, but whatever. I wanted to make an example that was appropriate. 36 squared is 1296. 191 squared. These numbers are going to get really big. Oh, geez. 36,481. 149 squared. 22,201. 126 squared. 15,876. 1,203. This is going to be the biggest one of all for St. Louis. Holy cow. 1,447,209. 1,447,209. Okay, I'm going to do a new list here for the 239. That's 57,121. I've done this one now. I'm going to keep marking them because I'm going to mess up. 243 squared. We have 59,049. That's this one. 224 squared. 50,176. You can see how these numbers get really crazy. If we're actually being honest, there are probably some computer programs that can do all this for you, so you don't actually have to calculate it by hand. Maybe spreadsheets that can do this for you, but we don't honestly have those right now. So I have my 1, 2, 3, 4, 5, 6, 7, 8, 9 deviations there. And now we're going to find the mean, find the variance. We're going to find the variance. We're going to find the mean of that giant list of numbers, right? We're going to find the mean of all those black numbers I just wrote, those crazy ones. So obviously a calculator is going to be useful. I'm going to have to type all these in, then I'm going to divide by how many numbers I had. 22201, 158, oh no, 158, 76, plus 1447209, there was a St. Louis one, 57,121, that was Randolph County, that was Moberly, 59,049, that's Chillicothe, 50,176, that was Fulton, and then 60,516, that was Mexico. I add all those up, I get that crazy number. I'm going to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, divided by 9, and I get this 194,436. I'm going to act like that 0.1 repeating bar isn't there. Okay, so we have this number, and then I'm going to have to do the last step, square root that answer, right? Square root this answer. And so I'm going to do second square root 194,436. There it is. 440.94. So I'm going to put 0.9. Right? And so our standard deviation is 440.9. And what does that mean? That means if I take one of my counties up here, I would say on average, I don't know if I would even have to say the word average, but I would say typically a county in my list is 440.9 or 441 places away from this mean that we started with right there, right? And that's called the standard deviation. Why do people even do this, right? What's the whole point? Standard deviation is good because, look, it used every single number in our list, right? If you think back, way back when we did range, when I do the range, guess how many numbers I use? I only use 2 numbers in the whole list, right? And so range is good because it is something you can do quickly and it doesn't take very much time. Like, look how much time this took. You usually don't need a calculator for the range, but the range is not maybe the best because it only uses 2 numbers out of the whole list. And standard deviation is what more statistical analysis is done with, because standard deviation involves every single number in the list. And look at all the stuff we did to all the numbers. We found the mean using every single number. Then we found the deviation of every single number, how far away it was from the mean. Then we took that number and we squared it. And then we took the mean of that list, and then we did the square root of that list. So the standard deviation is much more complicated, but it involves all the numbers, and that's why it is more preferable to a lot of educators, researchers, people in the intellectual community use standard deviation a lot, just because it's much more in-depth than, oh, I took the biggest number minus the smallest number, and there's my range, right? Range is good, but it's not necessarily as in-depth as standard deviation. So, all right, I'm going to put some questions up on the Big Ideas Math website. Hopefully you can give them a try. This is going to be the last chapter we do. I'm hoping to be able to finish this chapter right about the time that school is going to end here in about, a week and a half, 2 weeks, whenever. So thanks again for watching, and feel free to email me if you have any questions. See you guys.